So elements can be categorized into three types. That is metals, non-metals, and metalloids. Okay, these are the three categories of elements. Now, what are elements? Molecules having the same type of atoms combined together. Yes, molecules having the same type of atoms combined together. But my point is, why is it that we're having two different types of elements here, that is metals and non-metals? What is it that is differentiating some of the metals into metals? I mean, some of the elements into metals and some of the elements into non-metals. So in class 9, we learned about some of the properties, that certain elements have got certain properties and that we call them as metals. Other elements do not have those properties, therefore we call them as non-metals. Yes, this you have already learned in the class 9. But my question is, why do metals have certain properties and why do non-metals do not have certain properties? Okay, and that is related to this part here. Okay, see, that is related to this part here. You all know that atom have a particular atomic number, and due to this atomic number, it has a particular fixed electronic configuration. Yes, and when we have an electronic configuration, we have the elements filled in the shells. Yes, I mean, sorry, electrons filled in the shell. Yeah. And
Yes.
now, based on these shells, based on the different number of electrons present in the different number of shells, atom tries something. And what is it that atom wants? Atom wants to gain electronic configuration as that of nearest noble gas. Yes, as that of nearest noble gas. Yes. And in doing so, either the atom gains electron or loses electron. Clear? And whenever the atom gains or the loses electrons, definitely it will attain some charge. When the atom is gaining electrons, it will have a negative charge. When the atom is losing electrons, it will have a positive charge. Clear? Therefore, from the neutral atom, the atom has now attained some charge and therefore changed into a positive ion or a negative ion. Yes. Now it is no longer a neutral atom. The negative ion is called as the anion. Yes, and the positive ion is called as the cation. We have an idea till here, right? And you just now told me that ions either could be atoms or group of atoms. Either it's just one single individual atom or group of atom having a net charge. So here we are not concerned with the group of atoms because that comes under the category of compounds. You know that, yes. We are only concerned with the atoms which are same, right? Either one atom having a charge. Why? Because we are learning about elements. Yeah. So we are just going to focus on that. When one particular atom gains a positive charge, it's a cation, and when one particular atom gains a negative charge, it's anion. Okay. Elements, be mindful of this. Elements which have a tendency to lose electrons. Elements which have a tendency to lose electrons, therefore form cation, are metals. Elements which have a tendency to gain electrons. Elements which have a tendency to gain electrons and therefore form anions are called as non-metals. Clear? Now, metals and non-metals. Why do metals have a tendency of losing electrons? Why do non-metals have a tendency of gaining electrons? You must be able to relate this to the concept of electronic configuration. Let's suppose this: sodium with the atomic number of 11, neon with the atomic number of 10, and argon with the atomic number of 18. Yes, neon and argon, both of them are noble gases. When they are noble gases or inert gases, they will have an electronic configuration in which every shell or the last shell is fully filled. Yes, Arpa, I think that should be clear. The last shell will be fully filled in both the cases of neon and argon. Now, sodium does not have the last shell as fully filled. It has one electron in the last shell. Which is it more close to? Is it close to neon or is it close to argon? Hello.
Yes, ma'am, I'm there.
See, atomic number 11 and 10, obviously they are more close to each other, right? 18 is far away from 11.
Yes.
So sodium will want to attain the electronic configuration of like that of neon. And in order to do so, definitely it will be losing the electron. It will be losing the electrons. Argon, if we have chlorine here, which has an atomic number of 17, definitely it is more close to argon. It will want to gain the electron. Therefore, metals have a tendency of losing the electrons and non-metals have a tendency of gaining the electrons. It is a basic differentiating point between them as to why do they have different properties, opposite properties. Why? Because they are having opposite behavior. They are having opposite, this thing. They are behaving oppositely. Yes. One is losing the electron, the other is gaining the electron. So there's a clear-cut differentiation between their properties, and that is because of this behavior of metals and non-metals. Fine. And in simple words, if you are trying to understand this, we can also say elements which generally have less than half filled, this thing, shells, okay, less than number of electrons, which is less than half the number of the shell, the maximum capacity of the shell, they are called as metals because it's easier for them to lose the electrons. And the elements which are having more than half filled shell, they are called as non-metals because for them it's easier to gain the electrons. Clear? Therefore they are called as non-metals and metals. I think this should clear the basic difference as to what is a metal and what is a non-metal. Yes. Arfa, clear? Saad and Afshin have joined, but so why so late? I've explained the basics. We have started the third chapter, metals and non-metals, and I've already explained the basics to her. Afshin and Saad, respond, bacho.
Ma'am, I joined some other link, so yeah.
Saad, what's your reason for being late?
I forgot about the class.
Since you have an exam tomorrow, right?
Yes, ma'am.
So what are you doing right now? Studying or doing something else? Relaxation is also important. Relaxing or studying?
I'm just relaxing.
I was
I
expecting
forgot.
that
I
answer.
forgot about the class.
No
That's why.
worries. Fine. Good. So Arfa, I hope you will have no problem if I explain them again.
Yes, sure, ma'am.
Yes.
Okay.
Arfa is going on a little nap. Arfa, you can take a little nap, okay? No, ma'am. Okay. See, both of you, Saad and Afshin, very quickly, still here. We have started the next chapter, and that is metals and non-metals. Okay. Yes. Sorry for that. So both of you, Afshin and Saad, please understand this. If we are learning about metals and non-metals, the basic difference we want to understand, okay? These are two categories of elements. Elements are classified into three categories. What are elements? First of all, what are elements? Please do not judge me on my writing. What are elements? Elements are molecules which are having same type of atoms. Yes, same type of atoms. They are called as molecules. I mean, they are called as elements. Now they are categorized into three types: either metals, non-metals, and metalloids. Yes, non-metals or metalloids. We are not concerned about metalloids right now. We are only concerned about metals and non-metals. Okay. Now, from this, what do we know from class 9? We learned in the class 9 that metals are certain elements which have certain properties. Therefore, they are called as metals. Certain elements which do not have those properties are called as non-metals. Yes, this was a basic differentiating point in class 9. Now, the question is, why do metals have certain properties and why do non-metals do not have certain properties? Okay. Why do metals and non-metals do not have or not have respectively the certain properties? Okay. See. Now, this concept is related to the atomic number. Let's suppose this is an atom. Let's suppose this is an atom. Okay. It will have an atomic number. It will have an atomic number. And based on that atomic number, it will have a certain electronic configuration. It will have a certain electronic configuration. Afshin, camera should be on. It will have a certain electronic configuration. Okay. Now, when the electronic configuration is there, what will we see? That
Okay, ma'am.
certain number of electrons will be filled in certain number of shells. Yes, certain number of electrons will be filled in certain number of shells. Okay. Now, based on that, what does the atom want? I've already explained you these basics in the bridge course. What does the atom want? Atom will want to gain, atom will want to gain or attain, yes, electronic configuration as that of as that of near as that of nearest noble gas. Yes, as that of nearest noble gas. Okay, this is what the atom wants. This is what the atom wants. Okay. Now see, let's quickly take the example of sodium. It is between two noble gases, that is neon and that is argon. Yes, neon has an atomic number of 10, sodium has an atomic number of 11, argon has an atomic number of 18. Which one is it near to? Which one is it near to? Sodium is near to neon or argon?
Neon.
Neon, yes.
Neon.
Now, what is the, since neon is a noble gas, definitely it will have the valence shell as fully filled. It will have the electronic configuration is 2 and 8, and second shell is already fully filled for neon because it's a noble gas, yes. Therefore, sodium with the electronic configuration as 2, 8, and 1, it will want to lose this one electron and want to attain the electronic configuration like this, yes. It will lose one electron and will want to attain a electronic configuration like this. Whereas let's suppose chlorine with the atomic number 17, so 2, 8, and 7. It will want to attain 2, 8, and 8. It will want to gain one electron, yes, and will want to attain that of the nearest noble gas, that is argon. Yes or no? What are we seeing here? That the
Yes,
atoms are initially neutral, but they can also lose the electron, but they can also gain the electron based on their need. Based on their need. Therefore, first of all, this thing, atom which is initially neutral either can become a cation. What is cation? What is cation? Positively charged. Yes, positively charged. Positively charged. Okay. And when does the atom become positively charged? When it loses the electron. When it loses the electron. Okay. And either anion when it is negatively charged. And when
gains.
does it become the anion? When it gains the
Gains.
electron. Clear? Now this is one thing. Both of them are ions. Okay. The elements, mind it very careful. The elements which have a tendency to lose electrons, therefore form the cations, are metals, are classified as metals. And it is due to this activity, this behavior of metals, that they show certain properties, whatever we saw in class 9. Okay. Now elements which have a tendency to gain electrons, therefore to form anions, are called as non-metal. It is due to this behavior of them that they show certain properties or do not show certain properties, whatever can we say. Okay. I hope this point is clear. Yes or no? And why are they
Yes,
losing
ma'am.
or gaining electron? Why are they losing or gaining electron? Simple, to have the last shell is fully filled. Either they can have the last shell fully filled either by losing the electrons or by gaining the electrons. Clear? Yes or no? Saad and Afshin, Bachu, you need to respond. There's no sense in repeating it twice otherwise.
Yes, ma'am. I understand.
Fine. Therefore, metals and non-metals have this as a basic differentiating point as to why do they have different properties, why are they opposite, why are they behaving oppositely, because they are behaving oppositely. One is one is gaining the electron, the other is losing the electron. Metals are losing the electrons and non-metals are gaining the electrons. Is that clear? And yesterday
Yes,
also I
ma'am.
think I was telling this. No, that was in the other class. Fine. So this is the basic point here. Okay. And it is all related to the valency. It is all related to the valency to form the ions. Yes. What is valency? What is valency? This, how many number of electrons are lost or gained, is nothing but valency. Yes. Number of electrons lost or gained is nothing but valency. Maximum combining capacity, maximum combining power is valency. Okay, fine. Now see, from here on we'll be starting with the, in this chapter, what are we going to learn? We are going to learn 4 major topics. One is the physical properties of metals and non-metals. Okay. The other is the chemical properties, very important again, of metals and non-metals. Third is metals and non-metals, how do they react? Okay, react. How do they react? And this I will not be explaining here because I've already explained the basic. I will quickly be covering this topic. Okay, this is just based on this losing or the gaining of electrons. Fine. The fourth one is corrosion, and fifth one, very important, that is metallurgy. Clear? Basically, you know, the study of extracting metals or metals from their minerals. Okay, that's metallurgy. So we are having these specific topics in this chapter. Inshallah, let's quickly start them. So what do we mean by physical properties? What do we mean by physical properties? I'm starting the first topic here, that is physical properties. See, when I'm saying physical properties of metals and non-metals, it is very clear since their behavior is different. Metals and non-metals generally will be showing opposite properties in, you know, opposite physical properties. Yes. What do we mean by physical properties? That could be seen or observed, right? That could be seen or observed. Now, Quickly tell me some of the physical properties of metals and non-metals. You must have learned this in class 9. Arfa, I start from you. I'm starting this from you. Yes. Saad, any answer, bacha?
Ma'am, they are good
Yeah.
conductors of electricity.
Very good. This is for metal or non-metal? Non-metal.
Metal.
Metal. Excellent. So one is this, that metals are very good conductors of heat and electricity. What's the opposite for non-metals? They are not good conductors of heat and electricity. Yes. And why are we seeing this difference? Because metals generally have a tendency of losing the electrons, whereas non-metals generally have a tendency of gaining the
Gaining.
electrons. Clear? What other properties do we have for physical properties? Yes, very good, excellent. Afshin?
They are lustrous, shiny,
Good. Yes.
shiny.
Sonorous and lustrous. Metals show the property of luster and sonorous. Yes. Luster means shine. Luster means shining. Okay. It is metals. You will generally see the metals with a shining effect on them, and that property is called as being lustrous. Clear? And sonorous means what? What do we mean by sonorous? If you have a coin and that falls, okay, that will produce a very specific type of sound. Okay, and I don't know whether you people have heard that or not. In the beginning, like before some years when we were in the school, the bell used to ring by like this. Yes, what was that? That was that iron board or metal, something like that. Okay, that we used to actually hammer, and that used to produce a sound. A very specific type of sound is produced by metals, and that property is called as sonorous. That property is called as sonorous. Are you able to understand that, or should I say that again?
Yes,
Should I repeat that? Yes,
understood.
fine. What other properties? Acha, in case of non-metals, will non-metals be lustrous or sonorous?
They are brittle
That's
something.
written. See, always that's the right point, but always have it against to each other. As in metals lustrous, non-metals not lustrous. Okay, metals sonorous, non-metals not sonorous. Okay. And one important point here, when we are writing the properties, okay, in chemistry, when we are writing the properties, we will never say all. No, we will say generally because some exceptions are there. So we will write generally all metals are good conductors of heat and electricity. Generally, non-metals are not good conductors of heat and electricity. Generally, metals are sonorous. Generally, metals are lustrous. Generally, non-metals are not sonorous. Generally, non-metals are not sonorous. Is it clear?
Yes, ma'am.
That
And
is
they
how
have
we are going to
high density also. Metals.
metals. Yes, metals have high density. Why? Because they are generally solid at room temperature. They are solid at room temperature. I think all of this has been learned in class 9. They are generally solid at room temperature. Therefore, they have high density. Yes, since they are solid at this room temperature, since they have high density, they will have
No.
low or high melting or boiling points. Alpha. No one will answer. Alpha. Will they have high or low melting boiling points? If they're solid. Basic concept. Alpha got stuck or something. Hello. No,
High
Alpha.
melting,
Yeah.
high melting points.
High melting and boiling point, that is very clearly understood. Solid means high intermolecular forces of attraction, and to separate them, we need high amounts of energy, therefore high melting and boiling point. Yes. Whereas in case of non-metals, they will generally be having low melting and boiling points. Yes. Now see, the next point that was Afshin was saying about the brittle part. Yes. The metals are generally malleable and ductile. They are generally malleable and ductile. What do we mean by malleable and ductile? If we hammer them, okay, if we hammer the metals, we will be able to change them into very thin sheets and wires. If we are changing them into this thing sheets, they are called as malleable. Yes, that property is called as malleability. If they are being changed into thin wires, that property is called as ductility. Yes. Whereas if you are able to, if we are hammering the non-metals, they will change into powdered form, and that is what do we mean by brittle. Very quickly, all of you tell me the difference between hard, soft, and brittle. And one more question, are soft and brittle same?
No.
No.
No. See, what is hard? You know what is hard, right? Anything which is very tightly arranged, when not able to press it very easily. Okay, that is hard. What is soft? You must have seen clay, right? All of you must have seen clay. Is
Yeah.
that hard or soft? Is that hard or soft?
Soft.
Soft.
That is very soft, right? So clay is an example of salt. But if I ask you about those, please try to understand this example. Let's suppose I ask you about a very small piece of chalk, right? And if you apply some pressure or force, is it soft or does it change into the powdered form?
It brittles, so change in powder
Yes,
form.
it changes into the powder form, right? So that is what we mean by brittle, and the difference between soft and brittle should be clear. So metals, they are generally hard. Metals, they are generally hard. Some metals are also soft, but non-metals are generally brittle. Non-metals are generally brittle. Clear?
Yes, ma'am.
I'm writing all of these, don't worry. Should I write all of them? At
Okay,
least
ma'am.
first or yes. The first or second properties you can write. I'm writing. Wait. Alpha, all good?
Yes,
Suddenly you
ma'am.
became very less active, less involved in the class.
No,
Metals and
I'm not well. I didn't sleep, that's why.
oh, metals and non-metals. Okay. So first property. See, start from the basics. Start from the basics. Metals are generally hard. Metals are generally solid at room temperature. Yes. Whereas non-metals are generally solid at room temperature. Generally. What's the physical state for non-metals? We have learned this in class 9. Liquid also, we just have one non-metal in the liquid form, otherwise they're generally gaseous, okay? Acha, very important, we are just mentioning the states at room temperature. Because obviously if there's no room temperature, the states will change. Because the temperature is changing, okay? So we take the states at room temperature, therefore we are saying at room temperature, okay? Second, what should be the second point? Solids are generally hard. Yes, please use the term generally. Are generally hard. Non-metals are? Non-metals are generally
Brittle, brittle.
brittle. Okay. High density, low density. You can write it here. Okay. High density, low density. Fourth point. Generally have high melting and boiling points.
Ma'am, in the NCERT textbook, it is said that the non-metals are either solids or gaseous, except the bromine, which is liquid.
Bromine
So
is
solid.
liquid. And what are they saying? Solid. See, diamond
Uh,
is a non-metal again. It's solid at room temperature.
uh,
I'm coming to the exceptions. Okay. I'm coming to the exceptions.
okay.
And boiling point. Okay. Generally for non-metals, they will have low melting and boiling points. Fine. Next, write about malleability. Metals generally show malleability. Generally show malleability. Malleability and ductility. Alpha, what's the most malleable metal? Hmm. What's the most malleable metal? I'll stop the class uh, around at 9:20, before 10 minutes. Hmm. Because one is in sleep, the other one has the exam tomorrow. Hmm. Yes, Alpha. Tell me which is the most malleable metal. Bache, that is gold. What's the symbol for gold now? Gold is the most
EU.
malleable metal. AU. Now, generally, non-metals do not show malleability and ductility. Okay, fine. Next point. Next point. Good conductors of heat and electricity. Write it generally because we have the exceptions. Generally, good conductors of heat and electricity. Okay. Acha, you will not write that generally non-metals are insulators. No, you will not write insulators. You will just use the term not good conductors. Okay. You will not write insulators. The 6 point, lustrous and sonorous, generally they have the property of luster. Generally show luster. Not lustrous and sonorous. Okay. Fine. What else? Start. What else could be the property? Hmm. What else could be the property?
Colorless.
Huh?
They are not shiny. They are colorless or they are not shiny. Like
Shiny I've already written. Generally not lustrous. See, what you are saying is correct. We'll have it in different forms. See, generally the metals possess a very they do not have a very wide range of colors. Okay, they are not present in very wide range of colors. Metals, they generally are silverish, grayish, okay, or yellowish, golden. That's it. They do not have a very wide range of colors. Whereas non-metals are they have a very wide range of colors. Is that what you were saying, sir?
yes, ma'am. Type of.
7 point. Generally, again, metals. Metals generally do not have yeah. You can write the opposite of this for non-metals. Fine. Should I write the exceptions now? Should I start writing the exceptions? Have all of you written this?
Yes, ma'am.
Fine. What is the first point that we have written? Tell me. That is regarding the state, physical state at room temperature. Yes.
Yes.
Tell me the exceptions in that physical state. Mercury is solid, right? Mercury is solid at room
No,
temperature. Then what is it? Gaseous.
it's liquid.
It's
Okay.
solid at room temperature. Mercury.
Alpha, you need to sleep. It happens to me also, no worries. I also do this. Bache, all of us have learned this, I think, from the first class that mercury is liquid at room temperature. Mercury is liquid at room temperature. Mercury is liquid at room temperature. Yes, Alpha? No, it happens. Mercury is liquid at room temperature. That is why it is an exception. Okay. Apart from the joke, mercury is a liquid at room temperature. Therefore, it is an exception. But it's a metal. Therefore, it is an exception. Clear? And what's the symbol for mercury? Hmm.
Hg.
Acha, Hg. Good. Hg is the symbol for mercury. Good. Very good. Okay. So mercury is liquid at room temperature. Okay. Then for non-metal, bromine is liquid at room temperature. Okay. Bromine is liquid at room temperature. So I might also ask you, what are the two elements which are liquid at room temperature? Elements. I'm not even asking you to differentiate between metals and non-metals. Both of them are elements, yes. So the only two elements which are present in the liquid form at room temperature are mercury and bromine. Should I write the full name instead of the symbols? But are you able to understand Hg and Br?
Yes, ma'am.
Yes, ma'am.
That bromine is Br is for bromine and Hg is for mercury. Yes, fine. The second exception, the second point. What have we written? The second point. Yes, they are hard and soft, something like that. But so what's the second point that we have written regarding their hardness? Yes.
Yes, ma'am.
Behave like this. The second point is regarding the hardness and the softness of metals and non-metals. Yes. So we have written generally metals are very hard. Generally metals are very hard. Again, exception. First point. Sodium, potassium, lithium are very soft. Are very soft. They could be easily cut down with a knife. Are very soft. Okay. Whereas diamond, being a non-metal, is the hardest natural substance. Yeah. Graphite is also hard. Fine.
Ma'am,
So
what
these are
have
the
you written
exceptions.
after potassium?
Lithium, Li, lithium. What's the third point that we have written? Should I end the class? Should I end the class? Should I end the class right now? Saad is checking the time. How much time more is left? So I can tell ma'am, yes ma'am, you can end it now. You know, I've been in your position just like 5 to 6 years before. Arfa, Saad, but if are not responding, I cannot continue the class like this. Arfa, be active in the class. Apart from
Yes.
be active. What is the third point that we have written? That is regarding the melting and the boiling point.
Yes, ma'am.
So the metals which are soft definitely will have somewhat low melting point. That is very much understood. Mercury will have a low melting point. Yes, so that is the exception there. What's the fourth point that we have written?
Ma'am,
Colors.
mercury is already liquid, so why do we need a melting point for that?
Metals are solid at room temperature. Metals
But
are solid
mercury
at room
is,
temperature. Just a second. And we are talking about this physical state at room temperature. If I have to see, water is liquid at room temperature. If I have to freeze it, I need to freeze it, right?
yeah,
If I have to change it to ice, I have to freeze it. Are you getting that?
yes, yes,
And
yes,
we
ma'am.
will have a particular melting and boiling point for water also. I can change the state for that. That is, I hope that answers your question.
Yeah, oh, okay.
Understood? What's the next point, Bachu, that we have written? The fourth point, the third point, or the this thing, fourth point.
Conductors of electricity.
Alpha was the best conductor of the best metal. I mean, the metal which is the best conductor of heat and electricity. Very quickly for electricity specifically.
Silver.
What is this Ag? What does Ag stand for? Silver. Ag stands for
Silver.
silver. Yes. Then after Ag we have copper. Okay, so it's the best conductor of electricity. Now the exception here is that graphite, which is a metal or a non-metal. Graphite is a non-metal or metal?
Non-metal.
Non-metal. It's made up of carbon atoms. Okay, therefore it's a non-metal. So graphite is a good conductor of electricity, and that is the exception point here. Where graphite is a good conductor of electricity, but not of heat. But not of heat. Mind it. Fine. Now,
Yes.
what's the next point that we have written regarding the malleability and the ductility?
Yeah.
Yep. What's the most malleable metal? I just not told you. That's Au.
Gold.
Hmm. Now, next point is regarding the luster or the sonorous part. Yes.
Yes, ma'am.
Iodine, being a non-metal, is lustrous. This is the exception point. The next point is regarding I can check it myself. I just
Densities.
wanted to engage you people. Then density,
Density.
colors,
Colors and
colors. Density is all there in the liquid and the solid part. Okay, that will
oh,
depend on
okay,
the
ma'am.
state. Okay, colors. There's no exception in colors as such. Fine. That's it. I have mentioned all the exceptions here. Any problem here? No. Fine. The next property that I want to discuss is regarding the allotropes or allotropy. What is this? This property is possessed by carbon, and we have three different allotropes for carbon, namely diamond and graphite. So therefore, graphite and diamond are allotropes of carbon element. Graphite and diamond are allotropes of carbon element. Graphite and diamond are allotropes of carbon element. What do we mean by allotropes? The third one is fluorine. I'm not mentioning that. Yes. What do we mean by allotropes? Hmm. What do we mean by allotropes? When one element is existing in the same physical state but in different combination. As in combination as in different structural, not structural, different arrangement. Okay, that is what we mean by allotropes. So diamond and graphite, both of them are just having carbon atoms. Both of them are solid at room temperature, yet the number of carbon atoms present in both of them are different. Therefore, what are they? They are allotropes. What are they? They are allotropes. Very important. They are. It is to be considered at the same physical state. Both of them are solid. Diamond and graphite, both of them are solid at room temperature. Therefore, they are allotropes for carbon element. Clear?
Yes, ma'am.
Any other confusion here? Hmm,
No, ma'am.
fine. I wanted to discuss this one point here, and I'm not able to recall. I think I've already discussed that. Fine. Hmm, fine. So iron, copper, aluminum, magnesium, sodium, lead. Yes, I wanted to discuss the examples. So these are all examples. Yes. Any confusion regarding the example? What is fluorine? Is it a metal or a non-metal? Hmm. Is it a
A
metal or a
non-metal.
non-metal? What's chlorine?
Non-metal.
What's lead?
Metal.
Nickel?
Yes.
Sodium, potassium, calcium, magnesium, zinc, aluminium, iron, lead, tin, that is Sn, tin, okay, nickel, copper, silver, gold, platinum. All of these are what? All of these are metals,
Metal.
okay. Non-metals. Examples of non-metals: carbon, nitrogen, oxygen, sulfur, phosphorus, chlorine, fluorine, bromine, iodine. Okay, these are all non-metals. Clear?
Yes, ma'am.
Tungsten is what? Is tungsten a metal or a non-metal? Tungsten, you must have heard of this. Where is it? Where is tungsten used? Name one use of the tungsten. In the bulb filaments. Yes, in the bulb filaments. Why is it used? Because it has such a high melting point. It has a melting point of around 1200 or 1500 degrees Celsius. Therefore, when we pass electricity through that, it keeps on heating, therefore provides a glow, but does not melt because it has a very high melting point. And that is why it is used in that. Okay. So tungsten is also metal. Fine. I'm stopping the class right now. In the next class, I want all of you to be very attentive. Afshin, you will stay in the class right now. Arfa and Saad, you can leave. But in the next class, be attentive. And I will not repeat these concepts. Inshallah, I'll start from the chemical properties. Physical properties is completed, by the way. Saad, all the best for tomorrow, inshallah. Hopefully, you have a good exam. Any confusion regarding the second chapter, Saad?
No.
Fine. Arfa and Saad, you may leave. Afshin, yes, you wanted to
Yes.
have a revision for the first chapter, yes?
Yes, ma'am.
Actually, the point is we are very short on time because we have to finish the third and the fourth chapter also, and which is quite, you know, which needs much more conceptual clarity. So what we can do, we are not saying that we don't want to revise it with you. What we can do is we can have a better solution to that, and that is you can go through the recordings. I think you will be having the recordings, right, for the first chapter.
I don't know. I have to check.
You can ask the team; they'll provide you with that. Okay. You want my recordings or someone else's, whatever you want, you can get the recordings. They're fine. Now, first, Shami, you have some particular confusion in the chapter, or you want the full chapter to be revised?
No, I just want a revision for the half yearly.
Okay, as in the full chapter, right?
Yes.
So the better part is that go through the recordings, and if you have already understood the chapter, the best part is go through the NCRT, okay? And while you are going
Okay.
through the NCRT, because we just want to stick to the NCRT, yesterday also we revised all the questions regarding the NCRT only, okay? You just stick to the NCRT wherever you are having any sort of problem in the NCRT. I ask me that question in the next class. Or if time is not there, you can share that question with the team. They'll share the question with me and I can answer that.
Okay. Okay, ma'am.
Okay. Is that okay with you?
Yes, ma'am, it is.
Any specific topic, if you want me to revise, I can revise it with you right now in the next 10 to 12 minutes. Any specific topic?
I'll check.
We just have 10 minutes. When is your exam? You tell me that.
October 5 is my science exam.
October 5, today is 28th. So the next Sunday, inshallah, you are having your exam, huh?
Next Sunday?
Yes. Today is 28th. 5th October is on Sunday.
Um,
Shocking, huh? Sudden realization. Okay, no worries. If you have any confusion in between, you can please contact the team or contact me. Okay, whatever. I mean, you can contact the team. You can contact me through the team. And if there's any specific topic that you want to revise, I can revise it right now with you.
okay, ma'am.
Balancing of, see, there are just 2 to 3 important topics. Listen. Balancing, what is a chemical reaction? I think that should be clear. What is a chemical reaction, right? Simple
Yeah.
change in chemical composition is a chemical reaction. No change in chemical composition is a physical reaction. Fine. I mean, physical change. Fine. Now, chemical change is nothing but chemical reaction. Chemical change is nothing but chemical reaction.
Chemical
When we are
reaction.
having a chemical reaction, yes. When we are writing the chemical equation, which is used to, depict the chemical reaction which is happening, we write the symbols. And we need to balance that chemical equation based on the law of conservation of mass. Based on the law of conservation of mass, yes. Any problem in balancing the equation?
Yes, I
Did you
sometimes
see the
mess up the
recordings
calc.
before this? See, I will just
No.
tell you one method through which you should have seen that, because I have given you all of the students one method through which you can very easily balance the chemical equation. Okay, I'm quickly coming to that topic. See, Akshin, this is very easy to understand. Whenever you are having any chemical equation, okay, whenever you are having any chemical equation, so identify the different elements present in that equation. Identify the different elements present in the equation, okay. Then once you have identified the elements, categorize them as metals, non-metals, okay. Oxygen and hydrogen, these are the 4 categories that you will classify them. So I've just now told you the examples of non-metals also, yes. So you can, oxygen is also non-metal, but apart from oxygen, whatever non-metal is present, you will write in this category, okay. Then after
Okay,
that,
ma'am.
first step is that you will balance the metal on both the sides. Metal, I mean, the reactants and product side, right? First, you will balance the what? Metal. Okay. Let's suppose there are 2 metals in the equation. First, you can balance either of them, and then you can balance the second one. There is no order. But the only point is that first you should balance the metals. Okay. Once you have balanced the metal, then you will move on to the non-metal part. You will move on to the non-metal part, right? Balance the non-metals, whatever number of non-metals you have in the equation. But after balancing the non-metals, check that whether due to the balance of non-metals, is metals still balanced or not. Clear? Because that can obviously change that, right? The third step is that you will balance oxygen. You will balance oxygen. Fourth is you will balance hydrogen. Yeah. So I had this example, NCRT example. Let's quickly discuss that. Are you okay if we discuss it right now?
Yes, ma'am. Ma'am, can we like balance the equation of plaster of Paris and gypsum?
We can. I'm having this example from the NCRT itself. Discuss again.
Okay, okay.
The question says this. This is easy to understand. So like you can have. Okay. But see, this is the chemical equation, right? Now, see, you need to know the approach. That's it. You need to know the correct approach for a question. Okay. Now the question says balance this equation. I've already told you first identify all different elements present here. What are the different elements present here? How many different elements are present here?
Oxygen, hydrogen, and then copper, and then nitrate.
But nitrogen. See, whatever different number of
Nitrogen.
symbols are present, that means different element. This is one symbol, yes. This is another symbol. This is another symbol, this is another symbol. And you see the same symbols being repeated here, right? N, Cu, H, and O. Clear? Now, if we have N2 here, that is a different thing. But the element is same, that is N, right? Are you getting this? Even if we have NO3, we have nitrogen and oxygen here. Are you getting this, Bacho? We just need to know the element here, not the iron or something here. We have 4 elements here. Copper is a metal. Nitrogen is a Non-metal, right? Oxygen and hydrogen.
Non-metal.
Therefore, what's the first step that we need to do? We'll be balancing copper here.
Balance
How
metal.
many atoms of copper on the reactant side? How many
1.
atoms of copper on the reactant side? 1. How many on the product side? Therefore, it's balanced. Therefore,
Yes.
it's balanced. Now, the second is nitrogen because it's a non-metal. How many atoms of nitrogen here?
1.
How many here?
2.
2. I need to balance it. Acha, whenever we are measuring, whenever we are balancing the chemical equation, this will not change because this is a composition. We can just change the number of molecules. I think I've already told you this in the bridge course, right? We can just change the number of
Yeah.
molecules here, fine. If I have 2 atoms of nitrogen here and I need to have 2 atoms of nitrogen here also in the same molecule, what I will do? 2NH3,
2 and
right? I've changed the number of molecules. Now in this molecule, we can have 2 atoms of nitrogen. Yes.
Yes, ma'am.
Now see, if nitrogen gets balanced, yes. Now see, is copper balanced because of that? See that? I think it is balanced, right?
Yes, ma'am. It is balanced.
Now come to oxygen. Just a second. Come to oxygen now. Come to oxygen. Now see, this is our equation now. This is the one that we're going to, refer to, not this one. Because it has changed to this one, right? Now, oxygen atoms here on the reactant side.
1. 1.
On the product side,
1.
1. Therefore it's balanced. Hydrogen, how many hydrogen here on the reactant side?
3.
Tell me the correct answer.
6.
There's no benefit. Yes, 6. See, this is also for hydrogen. This is also for hydrogen. Just multiply them.
Okay.
This we discussed in the bridge course, right? But how many
Yes, ma'am.
atoms of hydrogen here
3 atoms of hydrogen.
on the product side?
Then 2
On the product side is 2, 2, right?
2.
Yes, 2. We need to make it 6. Can I have a 3 here? That will make the atoms 6. Now see, is oxygen balanced because of this?
No.
Therefore, what do I need to do? I need to add a 3 here, right?
3.
Now
Yes,
see, is
ma'am.
nitrogen balanced because of this? Nitrogen is copper balanced because of this?
No, copper is not.
What do? I add a 3 before
3.
copper, right?
Yes, ma'am.
Is that understood?
Yes, yes. Yes, ma'am.
Quickly, we'll practice one more question.
Okay.
And you will just solve this, okay? The approach should be understood, bache.
Okay, ma'am.
How many elements are present here? Tell me the correct answer.
Iron, water, hydrogen, oxygen. Only 3.
Iron, hydrogen, and oxygen. Okay. So iron is a metal, oxygen and
Yes.
hydrogen. There's no non-metal as such, right? Then first we will balance iron. What can we do here? One
We
atom
have
here,
to
and how many atoms here?
3.
Okay, so we will write a 3 to 4 Fe, right? Now this is the equation that we get, right? Now in this
Okay.
equation, see how many atoms of oxygen?
There 1, and in the RHA side it is 4.
4. So what do I need to do? I need to make the atoms on the reactant side also 4, right?
Yes,
So
ma'am.
I can change the number of molecules like this, right?
Yes.
Now see, is iron balanced because of this? Yes, it is balanced. Now see the number of hydrogen atoms.
No, it's not balanced in the RHA side.
What is not balanced, bache?
The hydrogen gas. Hydrogen gas.
Atoms.
Oh,
Hydrogen atoms. Okay. How many atoms on the
yeah,
reactant side?
8.
How many
The
here?
atom is 8, and it is 2 in the RHS.
Right. So I can just have a 4 here. That will make it 8.
Yes, ma'am.
Now see, is oxygen and iron balanced because of the balancing of hydrogen?
No.
What is it that we need to do? Why is it not balanced now? But it is balanced. See, 3 atoms of iron here, 3 atoms of iron here. How many atoms of oxygen here? 4. How many atoms of oxygen here? 4. How many atoms of
Oh,
hydrogen
okay,
here? 8.
okay.
How many atoms of hydrogen?
Okay.
It is a balanced chemical equation.
Yeah.
Is it clear?
Yes, ma'am, it is.
I hope some of it would be clear to you, right? At least the
Yes.
approach should be clear. You
Yes,
can
ma'am,
practice
it is.
using the same thing, and I would suggest you to get the recording of this topic specifically, that is balancing of the chemical equations. There I've practiced
Okay,
many
ma'am.
questions, so you can get some help from them. Okay.
Okay, ma'am.
Okay. Any other query?